Hello, ladies and gentlemen. Today we are going to be factoring special cases. Um, Half of this lesson is going to be the exact same with one small little change up to what we've done the past few days, all last week. And then the second part is going to be a little bit different. Not terribly hard, but a little bit different. Okay. So, students will be able to factor perfect squares and trinomials and difference of two perfect squares. We'll be talking about it in just 2 seconds. It's not too bad. But we're going to start off with this. This question you guys should know how to do. It's very familiar. And of course, there's no number in front of the x squared. So if we put a 1 and we do our middle lines, we multiply 1 times 36. And it gives me 36. We know that. Do my x, of course. Throw the negative 12 down there. At this point, I've got to find my factor pairs of 36. Now, again, we could do it one of two ways. We could use a calculator. Just do 36 divided by an x. Okay? Press Control and our T for table. And then we got 136. We have 2 and 18. We have got, watch out, 3 and 12, 4, 9, and 6 and 6. It's a great way of doing it. If you really want to, of course, we could also use our factor sheet. That's going to look like this in a second. Come on. And here we go. Alright, our factor sheet. Same idea as we did before. We're going to come over here. We're going to find 36. 36 is 136, 218, 312, 49, and 66. It gives me the same exact numbers. So, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now, we've got a positive on top and a negative on the bottom. When we got that, we come on over here. We look at our factoring using diamond. We talked about this earlier. And we're looking for, let's just double check real quick, a positive number on top, a negative number on the bottom. Okay. So, positive number top, nope. Positive, top number positive, bottom number negative. That's what we're looking for. Both numbers are going to be negative. So come on in here. And I'm just going to make everything negative. Both my small numbers and my big numbers. And after I do that, of course, I'm going to be adding these up. We've done it before. We'll do it again. It's not too bad. Put a plus. Oh, that's a bad color, guys. You probably can't see that. Let's try that again. Add those together. Okay, so negative 1, negative 36 is a negative 37. Negative 2, negative 18 is negative 20. We have a negative 15. We have a negative 13. And we have negative 12. Now, if you cannot add your positive negatives, please use your calculator. But after that, we're just going to find negative 12. Negative 12 is right here. Okay, so we got negative 6 and negative 6. So you've got x squared, or 1x squared if you want. You don't have to do that, though. We'll throw it in there. Why not? Minus 6x minus 6x plus 36. Split into two pieces. Alright. Now, 1 and negative 6, GCD. So, we GCD with the parentheses, 1 comma 6. We get a 1. Excellent. So, we can divide these by 1. We've got an x on both of these, so it's just going to be 1x. Remember, I find the smallest. So we got x2 and x1. 1 is going to be the smallest x. So that's going to be my parentheses. 1x parentheses. 1 divided by 1 is 1. X2 divided by x is just going to be x, where I'm just subtracting. Negative 6 divided by 1. If you do not know how to do that, please use a calculator. Negative 6. x and x, just cross that stuff off. And that's the first part. The second part, we've got negative 6x and 36. So negative 6 and 36. So I'm just going to go GCD 6, comma 36. Oh, it's going to be 6. Okay. 6. Don't forget there's a negative as my first term. I got to make this division part negative. X here, no X here, then we're good. Negative 6 divided by negative 6. So first I got my negative 6. Negative 6 divided by negative 6 is a positive 1. If you are not sure, please use your calculator. Okay, so 1. Got my variable x, and then 36 divided by negative 6 will give me negative 6. If you're not sure, use your calculator. So we have, if I notice, this and this are the same, so we have, excuse me, let's try that again. 1x take away 6. And if I also notice, we've got 1x and minus 6. Now here's the deal. That was done perfectly. It's done like every other one we've ever done so far. The difference is these two are the same. And when I get two of the exact same things, I can say that it is just squared. So I can write this whole parentheses. Okay, can I write the whole parentheses out? We got my 1x minus 6. Instead of writing it twice, what I'm going to do is I'm just going to write a square there. That's it. That is the difference between what we did before and what we did now. One small difference. And it's going to work here as well. Okay, I know we've got to multiply my first one and my last one. But it's not going to change anything. So 4 times 25 is going to be 100. And I've got 20 on the bottom. And all I'm going to do here is I'm going to find my factors of 100. Now, you could do it in the calculator or you could use this sheet. I do not care which one you do. Let's find it. So we got 100, 250, 425, 520, and 1010. Excuse me. So, write 100 over here. So 100. We have 2, 50. We have 3, no, 4, 25, 5, 20, and 10, and 10. Positive on top, positive on bottom. Come on over here. Okay, top number positive, bottom number positive. They're both being positive. And then I'm just going to add these up. Okay, so we have 1 plus 100 is 101. 2 plus 50 is 52. 4 plus 25 is 29. 5 plus 20 is 25. 10 plus 10 is 20. Which one's the same? Well, 10 10's the same. So we get 10. We have 10. And now we do the same thing we did before. So we have 4x squared, positive 10x, positive 10x, and positive 25. All right. Split these into 2. 4 and 10. What is my GCD? So, GCD, parentheses, 4, comma, 10. 2. All right. So we got divide by 2. We got x and x, x squared and x. X is the smallest one, so we just do my 1x there. Do my parentheses. 2x parentheses. 2 divided by 2 is 2. X squared divided by x is going to be x. Positive 10 divided by 2 is going to give you a positive 5, x and x, just cancel that stuff out. And I'm going to move it on. GCD of 10 and 25. So GCD of 10 and 25. 5. Oh, okay. So come on over here. 5 and 5, and we got x and no x, so we just use this. 5 parentheses, 10 divided by 5 is 2x. 25 divided by 5 is going to be a positive 5. So my two things are the same, so we got 2x plus 5. Okay, now that comes from right here. These two are the same. And then, of course, the second part is we have the stuff on the outside. 2x plus 5. Well, since these are the same things exactly, 2x plus 5 and 2x plus 5, I'm going to write this, parentheses, 2x plus 5, and just throw a little square there. That's it. All done. Okay. As you notice, this is basically the exact same thing. The only difference that we did before is if these two parts are the exact same, I only have to write one of them with a square next to it. That's it. Now, there's another problem. I think we're going to go... Oh, there's that. We're going to go on to this. Now, difference of perfect squares. So the difference of perfect squares, we're actually going to use one more sheet, and it's actually going to make our lives easier because we're not going to need any of this stuff that we used before. We're not going to need this. We're not going to need the factor sheet. All we're going to need is to know your perfect squares. And if you don't know your perfect squares, me being the nice teacher I am, I actually gave you a sheet on perfect squares. This way, there's going to be no question of your perfect squares. They are very important. Now, when I say perfect square, what I mean is, okay, so 1 squared is 1. So 1 times 1 is 1. 4, my perfect squares are 2 and 2. 9, my perfect squares are 3 and 3. 16, 4 and 4, because I have the same number multiplying to give me that 16. So it is perfect squares. That is all perfect squares is. That is it. Okay, so the majority of the ones we're going to be using is 1 through 12. Sometimes you'll use these other ones, but usually not the case. Okay, so now the big question here is, do you see how I've got the z here? Is z a perfect square? Now, you have to have both these to be perfect squares to be able to use this method. So when I do that, I'm just going to draw two arrows like this. And I'm going to figure out if these are perfect squares. So z is, well, it's z times z. There's two of them. Next thing, I've got 9, which is 3 and 3. Now, what's hugely important for this right here has to be a minus sign or a negative. If it is not, this will not work. If it is positive, this does not work. But since it is not positive, this is going to work just fine. Difference of perfect squares, we actually do our parentheses. We put our first part, we have z, z, z. We have our second, which is a 3 and a 3. And what we got to do here to end it up is you just put 1 plus and 1 minus. And that's it. All done. Now, I can't do the same thing I did before because when I did the before, they were the exact same thing. See how the 2x plus 5 and 2x plus 5 is the exact same thing? Over here, I've got z plus 3 and z minus 3. Not the same. This is the final factored form. Now, we could keep going with this. And it's going to work out very similar. So 64. Okay, I'm just going to pull this in the middle just to make life a little easier. And I know x is going to be x and x. 64, I'm pretty sure is a factor, perfect square. 64 is going to be 8 squared, or 8 times 8. Okay, since it's the same, xx, 8, 8, great. This is a minus. That means I'm just going to parentheses, I write my x, I write my 8, and then in between, I'm going to use 1 plus and 1 minus, and I am all done. Not terrible. Let me give you another example. Oh, geez, this one's going to be a little tougher. Not much tougher, but just a little harder. Start off the same way. 25, I know 25 is a perfect square, and if I don't, I come over here and say, oh, 25 is 5 and 5. 36, oh, 6 and 6. And I know x is x and x. So, same thing before. Now, 5 and 5, and I've got my x and my x. Since they're the same term, they have to go together. 36 is going to be 6 and 6. There's a minus in between, which means I can use this nice, easy method, which is 5x, 5x. We have 6, we have 6. I get 1 plus and 1 minus there. All done. All finished. Again, not terrible. Now, if you wanted to, you could say 25x squared plus 0x plus 36. In fact, it's the same way we did before, but that is going to be much, much harder. We'll do one more, and I will call it quits. Okay, so 16 and 81 is 16. Let's take a look. 4 and 4 is 81. Oh, 9 and 9. Great. So we have 16 is 4 and 4. X squared is x and x. 81 is 9 and 9. All right. So, got to do this one. So, we have parentheses, 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 parentheses. And we have 4x and 4x. We've got 9 and 9. We have 1 plus and 1 minus. Okay, that's excellent. Here's the thing, though. If I look at my numbers over here, now I know 4 is the perfect square, and I know 9 is a perfect square. But there's a plus in the middle. I can't do anything that time. But over here, I see 4 is a perfect square, and x, oh, is x perfect square? It's not. Minus 9. That's fine. I'm all finished. This is actually good to go. We are all finished with this factoring, this factor form. So, here's the deal. We have a few assignments this week. So, Monday, okay, we're doing IXL. Tuesday, I believe it's A6. Tuesday, we're doing IXL AA8. And then Wednesday, I'm giving you the day to catch up. Finish all your IXL and your Delta Math. And Delta Math. Delta Math. And that's it, ladies and gentlemen. Hopefully you already listened to my live conference before. If not, I hope this helps. If you have any questions, please do not hesitate. Feel free to text me on Schoology. I will help you. And that's about it. Talk to you later. Bye-bye.